Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
You go ahead and introduce it. I hadn't got that clear in my mind. Okay. Go ahead.
Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Carl Carlson.
Well, Carl, I was assuming I was going to introduce this one.
Assumptions again. Yeah. That could get you in trouble.
Well, where did this come from? You brought it up as we were chatting just before we hit record. And I was like, oh, we got to hit record. And then we kind of stumbled at the start there a little bit. But was this a question or where did this come from?
No, this is not a question. This is reflecting with some client work that I've done over the last year and just thinking about topics for podcasts. And in the reflection on client work is how often I run into the questionable assumptions that people make. So where, like as a consultant, where I can add value, and I'm sure you do the same, is guiding people into good practices on reliability or FMEA, whatever tools we're using. And a lot of that involves assumptions. So it's not it's just sort of a category of discussion as to what kinds of assumptions should we be on the alert for. How do we know when an assumption is actually being made? In other words, it sounds so real that we forget sometimes that it is an assumption. And so what are some of the big hitter assumptions that we see that can derail a reliability program or get wrong information? And what do we do about that? And what are some of the assumptions that really do work? And so I thought that'd be an interesting subject. I hadn't thought it beyond that. So it's going to be fun to sort of create it as we talk this morning.
Well, the hard part is that, not just in product development, but in everything we do. Like if I'm driving to an office someplace, I'm assuming that the Google Maps is going to say it's going to take 30 minutes and it'll take about 30 minutes, and 2.5 hours later, because I'm on the wrong side of Calgary, I realize that was a bad assumption because it assumed I knew how to drive my car and follow directions in a foreign city. But we make assumptions all the time that, the vendors are going to give us good parts, that the mold is going to be, well maintained all the way through the production run. We're going to do this. We're going to do. We have to make millions of assumptions. But when you narrow it down to and I give you a long list of really bad assumptions I've run into that just not just the reliability program, but the performance of the product going out the door. Ends up being reliability problems or quality problems or just a disaster. I mean, everything from, we're going to use the standard because that's what watches do. And we're doing a product that goes on our wrist. And it is just assuming that the standard would apply to their product just because they needed to test it somehow. And no.
If we can, in a podcast, share with readers, or sensitize listeners, I say readers, listeners, to the subject of assumptions so you can be aware of when an assumption is being made. That's like the first step, is seeing it.
And that's hard to do. It really, really is hard to do. It's because we do it so often and so glibly and so commonly. And it's like,
I'll give a silly example. It's not silly at all, but the different subject is meditation, which I use every so often. Mm-hmm. And when you're meditating, you're supposed to be aware of your thoughts. Don't change because of them, but you can see them flying by and stuff like that. Mm-hmm. So, and it's not that easy sometimes to be aware of your thinking because it happens below your awareness sometimes. Yep. And so it's very interesting. Just, there goes a thought. But I'm going to throw in two of them that just occurred to me while you were talking and that really kind of hit what you were saying on. So I'll just throw these out and then let's take up some other ones, time permitting. But one of them is you mentioned that is a vendor sending good parts. And that is a interesting potential assumption. Like if you're doing a process FMEA, you have to actually consider, are we assuming that the parts coming into the plant are good or not? And that really should be considered before you do the process FMEA, because if you do not assume that, and I think it's not necessarily a good assumption, then you have to have a good incoming parts inspection, good incoming parts station that can differentiate, or you work with the suppliers at their location to make sure you see their test data before they ship, that kind of thing. So
Yeah, no, see,
that's
you're
one that
not
just sort of
invited.
jumped up.
You're not invited to my program then, because that to me, it's overly cautious, and it sets a bureaucratic response to challenge, us defining assumptions. So I would much rather, I'm surprised you didn't mention doing an FMEA type thing or risk analysis type thing. If we've been working with this supplier for decades and we've got consistently good products and never raised an issue or field problem or catastrophic issue, and even if we did, they were very responsive and very helpful and stuff. I'm using an extreme example of a trusted partner.
Sure.
We can pretty much assume, based on our experience, that we're good. Now, the hard part is that when that logic then says, well, all vendors are good, that's the bad assumption. So I think it's more of a, what are the circumstances that lead you to believe that you're okay versus not okay, and look at that process of making decisions and saying, hey, we got a new vendor. My Uncle Bob's uncle talked to us about it, and they operate out of the back of their garage, and sometimes they move a lot, but they're okay. They're good guys. Well, let's do what you were recommending. Let's make sure we're doing first article inspection and doing all the other stuff, and let's check this and monitor it and everything else.
Yeah, and don't get me wrong here. I would not apply that to everybody, and I agree with what you're saying there. You basically, if you have data on suppliers, well, then that's going to help you know whether their parts are good and you can assume or not. If you don't have data, that's a flag. Yeah. Or as you said, if you have experience, which is similar, in other words, you have experience, which is usually based on data. But what we want to be aware of is we don't use blanket assumptions.
Right. And I think that's where the technique of recognizing assumptions is, well, what's that? How do we know that? If somebody says, oh, we'll make it up, we'll recover after we start shipping. All right. Well, what's the evidence that you're good at that? Or what's that based on? And, so it's part of it is it's the same with statistical analysis. If I'm going to assume it's this distribution, well, what evidence is there that that's appropriate? Now, the one I find oftentimes is, well, we're going to be conservative. And I challenge that again. It's like the 5 whys technique. It's like, well, what's that based on? What's the rationale that supports that decision? And the hard part with this process of saying, well, what's the evidence? Where's that supporting? Is it's not always a decision. It's just part of, it's not an overt decision. Not somebody saying, oh, we're assuming it's exponential. It's like, well, we did this analysis. And it takes a bit more astuteness, at least from statistics, to go, well, that analysis you did is based on the assumption of an exponential distribution or a normal distribution or whatever. But you have to know that. What's the evidence for you to be there? And I see this more often in the medical industry is they challenge everything. Everything's got to be documented, and supported and good resources and references. But most of us don't do that. We say, well, we think it's normal, so okay. What happens if it's not?
And note, if as a listener here to what Fred's saying, note what Fred is saying. He's saying challenge things, question, ask why. And that's really the key there, is because you know enough to speak up and say, well, where's the data for that? Or what's the evidence? Or what's your rationale for making that assumption? That's what we want people to do. So as part of this assumption discussion, speaking up and asking why and challenging assumptions is a good thing.
Well, even before I had the experience with my very first accelerated life tests, I'm going through Wayne Nelson's book on accelerated testing. And what he did in his book kind of set me on this path of, well, here's the assumptions I'm making, and here's how you check them. And it was like, well, do I do this technique or that technique? Well, the difference was, well, what's the underlying distribution? And I'm like, oh, well, I need to learn about how to detect what kind of distribution I'm dealing with. So I went off and did some of that kind of work. And I found it to be, because I could do the analysis either way, I would get two completely different answers.
Exactly.
Know? And they look beautiful. I could write a whole paper about it.
They're mathematically correct based on the assumptions that you have.
And so the part of it is that even when you're doing your own analysis, well, are these paired comparisons or are they, individual comparisons? What hypothesis test should I use? Challenge your own assumptions. That's where the practice comes in. And then you build more confidence to go, all right, Bill, I saw you do this, this, and this. Underpinning that as an assumption, is that valid?
I like to start every analysis I do, whether it's statistical or reliability analysis, or whether it's FMEA or any other tool, I like to start by documenting the assumptions that are going in.
Yep.
And so I never do an FMEA without documenting the assumptions that precede the FMEA. And I similarly with, if I'm doing an analysis, I'll say, well, what are the assumptions? And of course, that gets into the assumptions that go into the distribution that's being used.
Right. Now, so I think one of the techniques we mentioned there is to recognize it. One is practice it. Just ask that question yourself. But I think it's also when you can recognize an assumption being made, it's usually a logic element. And it might be a grand generalization, or there's a red herring, or it might be a false causation, or whatever all the techniques for logic traps that are out there. A causes B, B causes C. Does that really mean that A causes C? Maybe not. There's our neighborhood raccoon by the window. I guess we're still living in the woods. But sorry about that. But the idea is that be cautious of how people explain something. If it sounds like a generalization, or always, or we've never, or if there's not evidence or backing or something rational, but in the logic that leads into an analysis or a conclusion. I had one director of engineering says, "Oh, we don't need to worry about reliability at all. We only hire really good engineers."
Oh, wow!
And so it only took one question to destroy. This is, so what's your warranty rate? Oh, okay, that's 4 times your industry average.
Mm-hmm.
Really good engineers. Yeah, I appreciate that.
I mean, there's stuff that obviously it's very positive to hire good engineers, but you still need to understand reliability. You need to understand safety. You need to understand quality. Mm-hmm. There's a lot of things that go into good engineering, and that doesn't necessarily come about from the university. That's a different subject. Yeah.
Well, yeah, it's a whole other subject. But assuming that, they'll solve that problem. The other one I see in it's unrelated. Well, it's related to reliability. Everything is, of course, is we're going into detailed design, but we still have 4 inventions left to solve. We have 4 problems that we don't have a solution for, but we need to create an invention or some sort of breakthrough to do it. But we're only 3 weeks from production, so we'll figure it out. I'm like, I don't think so.
Yeah.
That rarely works out well.
I'm thinking back to my first encounter. Now we're going back in the 80s when I started encountering exponential distribution as an assumption.
Oh, yeah.
And that one, I had this really nice project. I was so fortunate because I was a manager of reliability at the time, and I had students that were coming through. We got reliability added into the core curriculum of interns, and that they would spend a few weeks in the reliability department as their overall interning. Mm-hmm. And so that was a really wonderful thing. And I thought, I'm going to find out if this kerfluffle over exponential distribution is real or not. So we have a database. This is back at General Motors. We had a database where we ran the vehicles from all over the world. We'd buy them and run them through the test track, Belgian blocks and test track, and we would root cause the failures. And that's part of learning about vehicles and designing better vehicles and learning from competitors. Mm-hmm. And it was a phenomenal database. So I said, let's start interrogating that database to see whether or not we're getting a exponential distribution or not.
Mm-hmm.
I mean, what a beautiful thing. We could look at chassis, we could look at electrical, we could look at the whole vehicle, we could cross-check it any way. And so this intern did it and came back with plots, and none of them were the bathtub curve. They were all more like a check mark curve or something where it goes down at first and then starts going up. But they don't have that. We didn't find anything in the plots that I had in that particular project that showed that flat portion of the constant failure rate. And so that opened my eyes that the data that we had at the time didn't match the assumptions that were going all over the place back in the 80s. I mean, into mill standards and into textbooks and what have you. So it's just fun to expose or to challenge the assumptions that go into analyses and into some standards. It makes its way into so many different parts of our work, including occurrence rating tables that we talked about.
Oh, definitely. My favorite though is I had it was a component vendor for an integrated circuit, and he says, "So how do you know that it'll work in our environment?" And he says, "Well, we ran these 15 standard tests, and we've never had a failure." Okay, you didn't answer the question.
Yes.
Those tests don't tell us anything whatsoever other than you passed the test. You ran 77 samples at 85C and 85RH for 1,000 hours. So what? What does that translate into real life? Oh, I don't know. We passed the test.
And this assumption question should go into everything. So if you're designing a test, what are the assumptions going into the test? Are you assuming that the parts you built are representative of what?
Oh, and then do you have a way to translate the test results into use conditions if you're accelerating it or stressing it in some way? I ran into this yesterday. It says, well, how would we test this? Well, what's the mechanism? Well, it's diffusion. All right. Well, what are the factors that would increase the amount of diffusion that you're getting? And, is it temperature? Try it, because sometimes temperature in soft polymers physically change the spacing of the polymer so that diffusion is inhibited. And they went, really? Yeah. Have you ever seen this in any of your accelerated tests, your temperature test? No. And he says, but you saw it in a week in the field. It's like, yeah, you might want to check that.
Wow.
But it's some of the ability to spot assumptions is experience and awareness of what are those things. And I think that's where the study and just you doing your own homework is one, here's a safe technique. Don't assume anything that your computer or your calculator tells you is correct. If it's on the internet, challenge it.
Well, I'll share one more story, and then I know we'll need to wrap up at some point. But because there's tons of stories on this, I did a project, and I won't go into the specifics of it because I don't want to violate confidential, obviously. But the project was a particular product that was developed in Japan, and it worked very well in Japan. It has safety implications, so it's very important. And it was brought over, a manufacturer brought it over to the United States and made an assumption that the environment the product was used in was the same. In other words, didn't take into account
Japan
that the environment in the U.S.
Japan to U.S., it's an island country versus a continent, basically, and temperatures. If you're moving from Italy to California, the Mediterranean climate would be similar. I could see it that way, but going from one country to another, when you have a country that's this size, there's a lot of differences.
And this had to do with weather and lightning and different things, and so no one even questioned it. The product went into production, and it had real problems in the field. And the problem is the environment that it came into was assumed to be the same, and it wasn't.
It wasn't, yeah. No, you see that all the time. I ran into that with one of the most weird phenomena I ran into is they took this electronics box, and they developed it in Colorado. It's high and dry kind of scenario. And they worried about ESD all the time. So they did all this protection for that, electrostatic discharge, because it was common in Colorado. And they decided they were going to open a new market in Brazil, and the fungus of this, it was an outdoor unit, and just mold and fungus and bacteria and all kinds of other things just ate the whole thing up. It just destroyed it.
Yeah.
And they
exactly.
never, it's just a little warmer. It's not a big deal. And we won't have to worry about ESD. Just because moving to a new environment solves one of the issues that you have, it doesn't mean that it doesn't create new issues for you. Mother Nature's is very creative.
And sometimes assumptions are correct. Like I had a client that said, okay, we're assuming exponential distribution, but then we went and looked at the data and they actually had
evidence
constant
of it.
failure rate. They had evidence of it.
Well, that's the hard part, is that the real challenge, isn't it, is recognizing it. And I think it comes down to, you just need to get practiced at doing this and recognizing logic flaws. And the easiest one is the generalization. Oh, that never happens. All right. Well, never's a long time.
That's a one-off.
Yeah. Or, oh yeah, no, in prototype building and testing, you get, well, that was just a prototype. That'll never happen.
We can explain that one. Yes.
That's right. We only had 10 samples and it happened in one of them. So that's one off. And I'm like, all right, well, that also represents technically 10% of your production.
Right.
Is that, let's do the root cause and really figure it out.
It's such a fun subject. I mean, I say fun. I mean, it can be very serious. And if you have, as a listener, stories about this or ways to be aware of assumptions in a better way, it's like techniques you use to surface what the assumptions are and question them, we'd love to hear from you on it.
Yeah, let us know. Head over to accendoreliability.com/go/SOR. A couple of ways for you to get in touch with us. Carl and I and the other hosts of the show are available through LinkedIn and through our About pages. And as I recognized the last time I did this, and on our comments on the podcast episode page itself or on article posts, there's all kinds of ways you can get in touch with us. So we really do appreciate that. Now, yeah, I think we're coming back to this assumptions one because we were just getting started.
I know we're getting started.
But I think we need to really focus on how do you recognize and challenge appropriately. I think there's a bit more finesse that we can pull into that.
Sounds good. I agree. I assume I'm going to have a good day today, so we'll finish off the podcast.
All right. Well, thanks, Carl. Talk to you soon.
Talk to you soon.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.